Heroku. I come from kind of the more like open source and web development development background, and have been in developer relations now for a little over 4 years. And yeah, super excited about Salesforce Functions. For those of you that maybe didn't see Trailhead DX, the name has changed from Evergreen to the Salesforce Functions thing. We wanted to be a little bit more clear in what we were creating and what we were sharing. It seems like Evergreen is going to stick around as kind of maybe like the underlying technology, like tooling underneath everything. But I think for like the kind of the public and the marketing of this new product, it will be Salesforce Functions. So hopefully that clears up any confusion as to whether it's Functions or Evergreen or what is that. Yeah, so I'm going to go through 3 things. Good morning. Yeah, I hope you're enjoying a cup of coffee or getting going. I'm in Seattle, in the U.S., so I'm just finishing up my day here. It's 4:30 p.m. over here, but I'm going to share a few things. So the first thing is just some slides, setting context and hoping to help answer what is Salesforce Functions, what can I use it for, and then I'm going to do fingers crossed a live demo showing kind of some of the tooling, the local development experience to create a function and build and debug a function. And then demo 3, or demo 2, part 3, will be a recorded demo showing a already deployed function and showing it being used kind of in maybe a more like realistic use case within your Salesforce org. And then we'll have some Q&A. So that is about it. I will share my screen now and switch to some slides. Let's see. All right. Okay. Let me know. I can't see you folks anymore, so let me know if you can't see the blue slide now that says introducing Salesforce Functions.
Yeah, we can see it.
Okay, great. So this is just the basic overview. This is actually a slide from Trailhead DX. For those of you that know of AWS Lambda, you can think of functions being a very similar thing as Lambda or even like Google Cloud Run, but natively built on it's actually natively built on being built by Salesforce, but natively integrated with the Salesforce infrastructure. So you will get the kind of the benefits of being able to kind of encapsulate a little bit of business logic or some sort of process in a single function, run it kind of outside of the constraints of like apex limits or governor limits or things like that, and also be able to reach out to the internet or even have those functions be invoked by an HTTP request coming in from the internet. But then, of course, like there will be safeguards and security around that stuff to make sure that the private ones stay private, or the things you want private to stay private. Languages, the first language is going to be node.js, but then Java and Apex are on the roadmap. And yes, that's like Apex, the language, but being kind of written as just an individual function that you can write and deploy and will be executed. One of the nice things, at least for me, coming from not a kind of Salesforce development background and learning more and more about it, as Heroku's integrated more and more into Salesforce, is that not only can I now like programmatically interact with Salesforce using Node.js or using JavaScript, something that I'm comfortable with. So maybe people at your companies, on your teams, who know JavaScript or Node or Java, but don't know Apex. It kind of opens up the ability for other people on your teams or at your companies to work on Salesforce development. But then another kind of big benefit is that there's this huge ecosystem both in the Java world and the Node.js world of third-party third-party packages, third-party modules, or things that you can do to rely on, not have to write your own code from scratch to, I don't know, make HTTP requests, or to, as we'll see later in one of the demos, like modify a PDF document and output that PDF, or do image manipulation or other things like that. You get to kind of leverage all the in the node world, these like, and all these npm packages, and then in Java, if you use Maven, there's a huge ecosystem of third-party dependencies that you can add into your project using Maven. It's going to be, as I said earlier, so the last item here on this slide, it's going to be like kind of very deeply integrated into Salesforce. And so you'll be able to invoke these functions using Apex itself. You'll be able to invoke them using Flow Builder, like steps within Flow Builder. You'll be able to invoke them using Lightning Web Components. You'll be able to invoke them also using platform events, or like CDC events, things like that. So lots of different ways to get in there. And I've actually kind of just given away some of my other slide here, but so you can see on the left side here, all these different ways to kind of natively invoke a function. So you don't have to worry about all the plumbing of like connecting these things on the left to invoking a function kind of in this central square here, central box on the slide. As I mentioned earlier, on the right side here, there will be this optional HTTP access to functions and services. So maybe that might be helpful with like integration with third-party services. Maybe you have some service that needs to call out and pass some data into your Salesforce org or into some sort of business process you have. Along the bottom on the right side there, this is, I don't know when this is going to launch yet, but this is something that has been highly requested, and they're planning to add in, the product team's planning to add in, is these managed data stores. You can think of these, if any of you are familiar with Heroku. Heroku has had for a long time Postgres as a managed data store and Redis as a managed data store. Postgres being just kind of your standard SQL database, Redis being kind of a key value store, but has kind of turned into a bit more than that, in-memory key value store. And then Kafka being like an event streaming platform. So you have kind of easy access to those in the future. And then last but not least, on the bottom left there is that kind of connection to your Salesforce org. So the code that you write within a function will be able to easily interact with objects and data inside of your Salesforce org. And the authentication and kind of the context of like, how to reach into that Salesforce org will be handled automatically for you. So you can think of it as like your function can use the Salesforce REST API, right, or the metadata APIs, things like that. But you won't have to deal with kind of the boilerplate that you would normally have to write yourself when you are want to manipulate some data within your Salesforce org. And then last slide here, I think last slide, just to kind of make it a little bit more concrete. These are some use cases that we've been thinking about, but we've also heard from some of the customers in the private beta, some different ways people want to use Salesforce functions. So on the left side, you kind of have like, business logic, things that are kind of more internal facing. So maybe you need to do financial calculations for like currency conversion maybe, or sales tax or something like that. In the middle, kind of have this category of like event-driven computing. So maybe that's like maybe you need to make like 5 different size versions of an image when an image is uploaded to Salesforce or added to Salesforce or something like that. Maybe it's like an avatar for someone, or maybe it's a product image or something like that. You could have those 5 different sizes, maybe, like high, medium, low quality generated, and kind of be triggered as event driven, right? Like using platform events or CDC or something like that. Demanding queries there on the bottom of that middle section is by demanding, that means more like CPU, high CPU or high memory requirements, which are things that are hard to do in Apex right now. because of memory and CPU constraints. So you will have kind of your function will run in its own little execution environment outside of all of those constraints. There will be I think there will be like a 15-minute timeout if it runs for that long, and kind of different boundaries, I guess, around that sandbox that you're working in, but much more kind of open and flexible than you currently have in the Apex runtime. And then you've got things that are kind of more maybe consumer facing. So you could even, on the bottom right there, like you could even think of building kind of a custom API, HTTP API endpoints over the data that's in your Salesforce org. So maybe you need to expose to some third party that you're working with or partnered with some specific piece of data that's stored, and kind of the canonical source of it is in your Salesforce org. You could very easily create your own kind of custom API endpoints just by defining functions. And then the top one there on the right side, is like something we've probably all run into, just standard like data validation, cleansing, deduplication, stuff like that. And I'll send this out at the end, so you don't need to worry about writing this down. But this is the URL to sign up for notifications when stuff becomes available. So Functions is not publicly available right now, as you might have seen in this first slide here on the top right there. It's in a closed dev preview. I'm not quite sure of the exact timeline of when things are going to be released, but I know near the end of this year or early next year, there's going to be a public beta of some sort where you can actually get your hands on things. But in lieu of that, and before that happens, I'm going to switch over to VS Code and do a little demo. So this demo is going to be a little bit more focused on like the local development experience and the tooling. If you don't use VS Code, if you're not using VS Code, kind of hint, it's going to be like more and more encouraged, and the product and engineering teams for Salesforce for the platform are going to try to encourage people more and more to use VS Code. It's very lightweight, it's fast, it's not like a heavy IDE, but it's also a lot more than just kind of like a basic text editor. And so I've installed the Salesforce extensions pack here, which I'll also send the link out to afterwards if any of you don't know about it. So an extension pack in VS Code is just like a set of extensions. So I have all these extensions here. And one thing that gives me then is, let's close this. One thing that gives me then is this like, I can hit Shift Command P and I can do these SFDX things. So it's like CLI commands, SFDX CLI commands, but I don't have to worry about the terminal. So I'm just going to start with creating a very basic Salesforce project. Save my stuff in a code folder. So this is just generating a bunch of files, generating some folders, kind of the scaffolding for if any of you are familiar with SFDX, it's like an SFDX project. So you can see here, I have a Force app folder in here that would have like my Apex classes and Aura pieces and layouts and Lightning Web components and objects and all that stuff. But we're not going to look at that right now. We are going to, let's create first thing I'm actually going to do is create a Scratch org. So again, I can do this all through the kind of this command palette in VS Code. I don't need to memorize the exact SFDX commands. Just go with the defaults for all of that. So, this is actually reaching out to my my dev hub that I've set up with SFDX and creating a Scratch org so that I can develop a function, work on it, kind of develop, debug a function, and then deploy it to the Scratch org to try it out within a Scratch org, test it out there, and then when I'm ready, deploy that or release that to my either a developer edition org, maybe if you want an extra step, or my actual like production org. Okay, so that's done. And now the next thing I'm going to do is actually create a function. So for this, there's no integration with the Shift Command P control palette in VS Code for the function stuff yet because it's so new, but I can open this integrated terminal in VS Code. Let's close that. And I can do things like say function create. I'm going to name it my function, and the -L there is for the language that I want to use. As I said, Apex and Java will be supported in the future. Right now, JavaScript and TypeScript are supported. I'm just going to go with JavaScript. And so again, this is just kind of like creating the boilerplate for me. It's like creating scaffolding, folders, things like that. If I go back into this, the folders here on my sidebar, I can see I now have a functions folder, and inside of that is a my function folder, and inside of that is this index.js. And I've got a test folder. I've kind of got this nice like kind of structure that is like kind of the right way or like best practices for doing Node.js development. And so let's look at this function a little bit. So this was generated, auto-generated for me, and here's the function that it created. Super simple, but I'll take you through the. Let's talk through first the parameters of or the arguments of this function. So the first one is this event that comes in. This is the data that is passed into the function from wherever it's being invoked, right? So if it's a platform event, there can be some data in that platform event that's like yeah, whatever you have in that, whatever you've defined in that platform event object within Salesforce. For Lightning Web Components, it could be some data about what is the user clicking on, or what data have they inputted maybe in the Lightning Web Component before clicking submit. And similarly, like this can be executed. You know, as I said, a function can be executed from Apex, and so in Apex you can just pass in a whole bunch of name value pairs, and that will come into the event. Context. This variable is used for, this argument's used for having a easy connection back into the Salesforce org, so that my code inside of this function, you can actually see down here just below a little bit. I can say context.org.data.query and actually run a SOCL query directly in the Scratch org that I just created. It's actually running that query against wherever the event came from, whatever org invoked this function. So a function is not tied to a specific org. It can be tied to many different orgs, and all those different orgs can invoke the function, and your context variable will have the context back into that org. And then you'll just get this nice logger object to kind of help figure out when there are problems, help understand what's going on. And if you have multiple functions running, also help to kind of aggregate all those logs together. So you can, maybe you have functions that call other functions. You can kind of debug those all together, look at the logging information from all of those in one place. So that's it. I'm going to actually run this function locally. Say maybe I just wrote that and I want to run it locally now. So I can go into the functions directory and my function, and I can do something. Let's function start. And this will take a little while. So this is going to build the function locally and set it up to be listening on a specific port. And I can make HTTP requests into that locally to test it out. And so while that's happening, I'm going to open up another terminal here, and I'm going to create a little payload. So this is going to be what's passed in the event object. So I'm just going to create some data for that. Let's say touch payload.json, just create an empty file. Here's that payload.json. And I'll just do something simple like message. Something super simple. Let's see. Actually, one thing I did forget to show you, though, I was going to show is for those of you that are comfortable with the command line and do like getting in there, we can say sfdx help function, and you can see kind of all the different things that you'll be able to do as you're developing functions. So we've got these subcommands here. We've got build, create, delete, deploy, invoke, list, release, start, and update. So you can get a sense for all the different types of kind of core or base level activities that you would use to develop, test, and deploy, and use a function. Let's see, what else did I want to show? Okay, actually, yeah, one thing that's I think is pretty cool is not specific to function, but the debuggability, the ability to kind of easily debug functions that are executing. So if I go to my index.js, I can actually add a breakpoint here. And so it's gonna pause execution there. And I'm actually going to use the debugger built into SFDX. Before we click play on that, though, I want to make sure that this function has finished. Yep, it says ready to process signals here. And then you can actually see right here, it says debugger listening. And so when you do start a function locally, you automatically get this debugging functionality built in. So if I go back here and I click play, I got some errors. That's okay. Could not read source map. That's okay. So what I'm going to do now is go back to that other terminal window and invoke the function. So we're going to run this whole function, pass that payload.json data into it, which is just, message, hello, Sydney. And the execution will pause and we'll get to see kind of do some debugging on the left here. And then we'll see some output from that function. So let's do function invoke. You can see I've tested this before. That looks good. Oh no, my payload is. That's good. Okay. Okay, so before we look on the left side there, one thing I wanted to point out is it says using default username, hey Sydney, login credential to initialize context. So again, just want to make this clear, like this function, the execution of this function, the code inside of it has access to that scratch org that I just created. There's no data in that scratch org, unfortunately. Like I'm doing this select ID name from account. There's no data in the account object in the scratch org by default, or how I configured it. So nothing's going to be returned. But I just wanted to make it clear again that like it's super easy to run SOQL queries that are reading or writing to your Salesforce data from within the function, and not just when it's deployed, but also while you're testing it here and debugging locally. But you can see, yeah. So my breakpoint worked here. Execution stopped here, and I can see here's this event parameter that was passed into the function. And if I opened up here, here's the data. So event.data. And let's make this a little bigger. You can see the message was hello Sydney. So that was passed into the function and it can do things with that data. Here's that context variable and here's that logger also. So if I wanted to, for some reason, dig into those or better understand what's inside those objects, I could check those out. All right, let's continue execution. There we go. So you can see here that invoke command that I ran on the command line really was just making a post request, but it was kind of mimicking as pretending that post request was coming from something within my scratch org that invoked it. And here's the output from it. Again, no records because there's no account data in there and total size is 0, but it was a successful completion. That's this last line that was being outputted here. Oh, I'm sorry. Actually, that was the results object that was being outputted here. If we go back to this other window here, we can actually see this is the logger.info being written here to the terminal window in which I ran SFDX function start. So you can say it's saying, hey, invoking my function with payload, and that matches up with this logger.info here. And then it outputs this JSON object, which is this line 19 right here. Yeah, so that's it. That's the quick kind of example of what a local development process would look like. The next step that you would generally take with this is to so we would control C to stop the function from running locally, and we would do something like function, is it deploy? Yeah, we would do something like function deploy, the name of that function, and Also, we could give it like an alias to a Salesforce org. By default, it would go to the whatever the default one is. If I wanted to go to that Scratch org, but I could send it somewhere else. Cool. Yeah. So let me switch over to a video now. So this is jumping into 4-minute demo of an event-driven high compute use case. For those of you that have heard of it, this is doing something called within the function, the code in the function, it's doing something called the traveling salesman or traveling salesperson problem, where it has to kind of given a bunch of latitude, longitude points, it has to, we want the function to calculate the most efficient route connecting all those points. So maybe you are a delivery driver that has to go to a number of different addresses, and you want to, one, save time by making an efficient trip, but also two, save fuel by from the truck that's driving around in that to all of those points. So I'll jump in here. Speak up. Someone let me know if you can't hear the audio in this. Actually, I think I need to switch my presentation mode to make sure you can hear it. I need to present a Chrome tab, and then I will present this one. Okay.
Into yet another demo of how you can use functions. In this new world of being remote, customers often want services to be delivered to their doorstep. And as a provider of one such service, we have here several delivery partners that we work with, a fleet of vehicles that we use for the delivery, and the services that we actually deliver. Today, we'd like to build a node Salesforce function such that given the set of services that we have and a fleet of vehicles, our function can calculate the delivery route and waypoints to help us come up with a delivery plan that will help us optimize the time and resources that we have. This is popularly known as the traveling salesman problem and is a high compute use case that can benefit from some elastic scale. So let's go ahead and take a look at our function. Here we have in our Salesforce project, our function that looks very similar to the function that Joe just showed us. And the first thing we do in our function is to go ahead and grab the tour name and the account ID from the incoming platform event payload to our function. Then we'll go ahead and use the pre-authenticated Salesforce context to the function to query the vehicles that we have and the services that we have in our org. Finally, we'll go ahead and create a new client using the Google Maps NPM library, set up the variables for the TSP search, and then go ahead and run the TSP solver. Now, in order to make our updates to Salesforce in a more transactional manner, we'll go ahead and create a new unit of work instance. We'll then create a new S object for the delivery plan that we're going to create, and similarly, also create the delivery routes and the delivery waypoints. We'll register these new S objects to the unit of work that we just created, and then go ahead and commit that entire transaction back to our Salesforce org. And that's it. That's all we needed to do to write our business logic to develop our function. Now let's see how this function works. For the purpose of this demo, I already have this function deployed to the platform. And guess what? This function is listening on a route planning platform event such that when this event is emitted, we will go ahead and trigger our function. I also have a flow right here that is watching for any new deliveries that are created. When a new delivery is added to an account, our flow will go ahead and create a new platform event, which is that very same platform event that our function is listening on. So let's take a look at how our function works. Now we'll go back to our accounts and create a new delivery today for Acme deliveries. Let's call this TDX swag drop off. And when we create this, what happens underneath the covers is that flow that we just saw gets triggered, which in turn invokes our function. In a second here, we should see that our function will produce a new updated delivery plan. And there we have it. Our new route for delivery and the route order appears. And that's really how simple it is to create a function that can be triggered by an event and help you solve high compute use cases.
Cool. That is it. So that's all I have for demos. What is it? It's a little after the hour. So got time for Q&A now. Happy to try to answer any and all questions you have.
There are a few questions posted in the chat.
Okay, great. I can open that up and check it out.
Emmanuel tried helping answer some of them.
Oh, okay. Thank you, Emmanuel. I could not see those as I was demoing, but I will, let's see, start from the top. Let's see, Shiva. Salesforce Evergreen is more about establishing microservices in Salesforce, or is it more around getting around to avoid the limitation of Salesforce APE? It's a little bit of both. I mean, I have heard, like forward-looking statements slide protections, but I have heard that the team working on it, the product team, does want to kind of expand functions to support services, so like persistent, kind of constantly running services. But I wouldn't say right now that's not the plan. It's not for microservices. It's more these kind of like small bits of code that are functions that can be executed on demand. But they're not going to store any state locally. Like, they're not going to keep state in memory. They're not going to keep state in on disk or anything like that. They will have access to data stores in the future where some state can be stored outside of like your standard Salesforce data model. But mostly they should be kind of like these little stateless. I need to do some business logic, and I would like to do it either. So there are two options: either synchronously or asynchronously outside of my Salesforce Apex runtime. Let's see.
Chris, yeah. Adam Best here, if I may. I heard a great podcast from I think Chris Peterson, director at Apex, and he put it like this. He said, "Look, we've got a great multi-tenancy environment, the power of the platform." At Apex, I think the state was 3 megabyte 2015, and it went up to 6. But it's really just extending that and opening that up without really touching the core power of the platform to over 1 million libraries. So yeah, it's more about extension of the platform rather than the limitation per se on the Apex itself.
Yeah, that makes sense. And then as like Shiva said in his next question, there was like, is it expanding or open to the open source domain? It is that, right? Like, it's opening this up to many new developers, hopefully, but also other people's code, right? Like third-party open source packages that you can use to solve problems instead of having to write all the code from scratch. Let's see what else is in there. It is, so one thing, it is it's functions by design is going to built to be very scalable and kind of elastically scalable. And I don't exactly, like, we haven't figured out the pricing model for this stuff yet, but it is going to be kind of tied to like a usage-based pricing model in some way, in that, like, if you won't be charged, I don't know exactly for sure, right? But that you won't be charged if the function is not doing anything. But as you scale up, you need to run kind of have a function being invoked in parallel, hundreds or thousands of times. You could do that. We'll take care of all of the scaling concerns or needs for you, and you'll be charged kind of based on CPU and like memory usage by those functions invocations.
That's very similar to Heroku model.
Yes, yeah, it's very similar to Heroku model. And like, to like pull back the covers a little bit, it's actually a lot of the Heroku engineering team that is building the functions kind of underlying infrastructure. So it's kind of taking a lot of the knowledge and wisdom of Heroku's product and engineering teams, and connecting that to Salesforce in a way that's much kind of deeper and native integration than Heroku is right now. Heroku's not going away. Like it's still going to be the same. When you do want to run persistent kind of long running services like web apps that are built in Node or Java or PHP or Python, Heroku's still the place to do it. But functions will be for functions. Let's see. There's a question about Scratch orgs. Yeah, so for it looks like Emmanuel maybe has answered it really well for me. For those of you that haven't used Scratch orgs, so me as like a fairly new Salesforce developer, I came in and learned about developer edition orgs, started being able to do things there. But then I kind of learned more and more about SFDX, the CLI, and Scratch orgs, and being able to use source code and source control to define the changes that I want to make to an org. And it's been super powerful. So I would encourage, and again, I can send out some links to like Trailhead modules and things like that. I would encourage you to check out how to use Scratch orgs as part of your development process. One question
is also from Ravi, asking about how do we try out Salesforce Functions if they want to do it in their own org.
Yeah, it doesn't require any changes to your org. It's not public. There's no public beta or anything that's available right now. I don't know the exact schedule, but it should be like the end of this year, early next year, when there will be a public beta, which you'll be able to test out and try out with developer edition orgs and Scratch orgs. It doesn't require any, it doesn't require anything like fundamentally changing about your existing Salesforce orgs. As I showed earlier in one of those slides, like there's all these different ways to invoke a function, whether it's platform events or a CDC event or a Lightning Web Component kind of user interaction or something like that. So I know the product team is trying really hard to not kind of require you to change anything fundamentally or kind of difficult to change about your org.
So where does this get hosted, Chris? Like when you runtime, just looking to the back end of things.
Yeah, under the scenes, like it's not going to be a secret, but like it's using Kubernetes. It's all running on right now. It's all running on AWS behind the scenes. Again, so like Heroku runs all on top of AWS, and as the Heroku engineering team is building most of the team building functions is from Heroku engineering. They're using the tools they know and the knowledge they've kind of accumulated working on Heroku. So it's almost, in some ways, you can think of functions as like kind of the next iteration of Heroku's technology stack or Heroku's kind of platform. That's not perfectly accurate, but it is like, it's running on AWS. It's using Kubernetes behind the scenes. It's running your function inside of a container, inside of a pod running on Kubernetes. But we're abstracting all that stuff away, so you don't have to worry about AWS, Kubernetes, all the knowledge or all the language and kind of terminology required for Kubernetes. But you'll still get kind of the same like trust guarantees that you expect from Salesforce.
And if the functions are accessing Salesforce data, that's through the existing API framework, or?
Yeah, it is. So again, like that context variable within the function is effectively just using like the REST API or different Salesforce APIs that are publicly available to you. So, you could do all this function stuff yourself if you and your company wanted to spend hours and hours and hours like building this infrastructure and like building the libraries to support like managing the authentication, all of that stuff to reach out to your Salesforce, to an API to reach into your Salesforce org. But that's a lot of work. And then that's a lot of stuff to maintain after you've built it. So I would recommend you don't do that. but yeah, it's using APIs. One other question that comes up when I do say that people have is like, will that kind of draw down from my API quota? And I don't know the exact answer to that yet, but I know the product team has received this question a lot. And I think what they're trying to figure out is a way to like whitelist a certain amount of API requests coming from your function into the Salesforce APIs so that they don't draw down on your kind of the amount of API requests that you have with your current Salesforce contract. Let's see. What sort of time delay responsiveness of function invocation is to be expected? That's a good question. There's going to be, again, they're still figuring this out, but there is kind of like a cold start when a function hasn't been invoked for a while, where it'll take a couple seconds for the function to be loaded and started up. And then once a function has been run recently, I don't know what the timeout period will be yet, but it'll be warm and very fast or very low latency for future requests. But then, some customers have given us feedback that, well, doesn't that mean that like, multiple function invocations are happening in the same piece of memory, right? Like in the same node.js process. And that's true, right? So there's kind of this trade-off between like, you can have every single function invocation start from a cold start. And in that case, like there's no shared memory, no shared data, no shared nothing between each invocation. Or you can have like, choose to say, hey, I want, lower latency, and I'm okay if one function shares or has some kind of overlap in data. One function invocation shares or has overlap in data with a second function invocation. So there's some complexities we're trying to figure out there to balance like latency with security of data. I don't know the answer to this question here. So Craig Donnelly asked, does the support for Apex imply a local Apex runtime? I mean, the answer is yes. Someone actually internally at Salesforce has figured out how to run Salesforce Core on Heroku as like a test project. I don't know exactly, like, is it going to be the full Apex runtime? Is it going to be a subset, like a lighter runtime that's running for a function? I don't know exactly what that's going to look like, but yes, a local Apex runtime will be used to run your function. Let's see. Craig asked another question that said, what are the plans for where is this used? Dependency analysis of field usage and functions. And I'm not following what that question is. If anyone knows what that is, or if Craig, you're still here, if you can clarify that, that would be great. There's another. Oh,
as
go
much
ahead.
as tracking where functions are being used and knowing if you change the function, where does it have a spill effect on?
I see. Yeah, I don't know. Actually, I don't know the answer to that question. I will. I'll pass that back to the product team and see what they say. Is the question more about like the dependency going from the changing objects in Salesforce and the dependency that functions have on a specific schema within your Salesforce org? Or is it going the other way where it's like changing a Salesforce function? Yeah, I guess which way is the dependency, or is it both ways you're interested in?
Probably, how there's a dependency API,
Yeah.
and now you can't delete, for example, a web component if it's being if it accesses a field and vice versa.
Right. Okay. Yeah, it makes sense. I'll ask that of the product team and see if they have anything if they know anything or have anything to share about that. But at the very least, I'll make sure they get the question. Let's see. Will SOCL queries, DML, et cetera, made by the functions back in the connected org count against? So I answered this one, I think. Will they count against API limits? We don't know exactly yet, but the goal is to simplify and to like make it easy for you to understand how much of your API limit is being used and by what places. For instance, if any of you use Heroku Connect to synchronize data between a Postgres database in Heroku and your Salesforce org, Heroku Connect uses the Salesforce APIs to read and write data to and from your Salesforce org. And all of those API requests are whitelisted, so they don't count against your API limits. I don't know exactly what it's going to look like for functions, but I have heard some mumblings about it, those requests being whitelisted or separate in some way than your API limits. And then another question at the end here: are functions called through only platform events, or is there any other way to invoke functions? Yeah, good question. So there's going to be many ways, and please share feedback if you want additional ways too. The product team wants to hear it, but it will be, I think the initial functionality or the initial way that's going to be released to invoke functions will be through Apex. Mainly because that gives you a lot of flexibility in terms of like different ways you can then invoke a function, right? If you can invoke it from Apex, you can also invoke it from Flow Builder by running an Apex, a piece of Apex code. So it's going to be Apex execution, invocation for functions, and then it's going to be probably platform events and CDC events will be supported. From there, I don't know where it's going to go, but that kind of opens the door to a lot of different things you can do, right? It effectively gives you the ability to invoke a function from a Lightning Web Component if you can use Apex. That's all the question. Oh, there are more. Sorry, just wondering. Okay, so yeah, so another question says, just wondering if it requires pushing source code or will it support compiled artifacts, like deploying a jar file for Java. Behind the scenes, the build process is happening or is using something called a build pack, which actually was a Heroku invented concept. Cloud Foundry uses it now. And Heroku and Cloud Foundry are actually working together to create kind of V2 of this build pack concept. So if you go to buildpacks.io, you can learn more about this if you're interested in the nitty gritty details. It's a cloud native computing foundation project. And it's kind of like the engineering folks working on it think that like Dockerfile is the wrong abstraction to force a developer to learn about and to understand to be able to deploy their code. They want to make it easier. And so that's what the Build Packs project is focused on, which is a long way to answering your question, in that you'll be able to push your Java source code just as source, or you will be able to push a jar file if you want to compile it yourself, or maybe you have your own CI/CD process with Jenkins or something like that that spits out some sort of jar artifact. You'll be able to deploy that very, very simply, just in the same way you would deploy by pushing your source code. Let's see, Craig had a clarification. He says, I'm thinking of the where is this used button on object fields in Salesforce setup. Yep. And the dependency API, right? That's what I think I missed who explained, help me understand that. But yeah, I'll find out more details on that from the product team. Let's see. Additional language or runtime support. Yeah, share with me what you want. And the product team is prioritizing based on customer feedback. For example, during Trailhead DX, we had a survey that we were asking folks to fill out when they watched either the demo or the episode about functions. And there was way more interest in Python support than we knew there would be or thought there would be or expecting. So that's great data for the product team. I don't know about Dino support, but that would be cool. But one thing that is really cool actually about the BuildPacks project, buildpacks.io, and I'm not sure if this is going to transfer over from kind of Heroku development to Salesforce Functions development, but right now, like Heroku has officially supported languages. There's like 6 of them, well, 8 technically, but Python, PHP, Ruby, Node, Go, Java, Scala, and Clojure. Those last three all like JVM languages. But you can run Dino on Heroku right now. Like someone created a Dino build pack. Sorry, for those of you that don't know what that is, it's a new JavaScript runtime that has kind of just been released about a month ago. It's been created by and the people working on it. Ryan Dahl is his name, and he's one of the people that actually, well, he invented Node effectively, so it's getting some attention. But anyway, you can run really any language you want on Heroku by creating a build pack for that language, which just describes how the build process works for that language. And so because Salesforce Functions is using build packs under the scenes, like under the covers to build your functions, pull in the dependencies and figure out how to actually start the runtime and execute your function, it kind of leaves the possibility that, oh, maybe, I can run any language, like .NET Core, for instance, because all of these will, as I said, they're on AWS, and right now they're all running on Linux systems, and so there's no Windows support, but you can run .NET Core on Linux. So please, I'll send Vemsi the a bunch of links and things like that, and you can share your feedback, and the product team would be psyched to hear what you have to say.
Yep, that'll really help, Chris. I'll publish that in our community group, and that'll go.
Cool.
That's great. Thanks, Chris, for taking time. Joining the group. Thanks everyone for joining, and thanks for all the wonderful questions. Unfortunately, we don't have the hoodies and vouchers this time, but hopefully we'll get that again.
Yep.
Sorry, Chris, can you just post that SFDC sign up link again?
Yeah, I'll put it in the chat right now.
Yeah.
There you go. Yeah, so that's just to sign up for future emails and notice when there's news generally. But yeah, I'll send out some additional links to a survey, some Trailhead modules, and any other things I can find that I think would be interesting.
Great. Thanks everyone. Enjoy your rest of the day.
Thank you.
Thanks, Chris.
Bye, folks.
Thanks, Vamsi.
Thanks, guys. Bye.